Thank you very much. And hello, everyone. Thank you for joining us today on this webcast on data engineering with AWS. My name is Archana Krishna, and I'm a senior business intelligence and analytics consultant at Thorogood. I'm joined by my colleague, Emily Dentinger, and we're both speaking to you today from Philadelphia. You will see our contact details up on your screen, and please do feel free to reach out to us in case you have any questions. Got email and LinkedIn details up on your screen. We'd be happy to connect and speak with you. So a quick look at today's agenda. I'll start off with an introduction to Thorogood. I'll then share some thoughts on data engineering broadly, its relevance today, and how it has evolved with time. Emily and I will then walk you through common patterns where data engineering comes into play and what AWS offers in this space. We'll have some demos as well, so you can see some of this in action. So who are we? Thorogood is an independent and specialist business intelligence and analytics company with a focus on data engineering, data science, and data visualization. Our approach is rooted in understanding business goals and using the capabilities of technology to meet these goals. So really, customers and business objectives are at the forefront of our approach. We are a global company with offices and consultants in Asia, Europe, and the Americas. We offer a full range of services when it comes to data and analytics. So that will be data and technology strategies and roadmaps, end-to-end implementation of cloud solutions, user empowerment, and data and analytics services. Our customers are typically multinational blue chip customers, and you can see a sampling of them up on your screen. They draw from a range of sectors, including consumer goods, the pharma space, and financial services. We are an independent company, and this independence allows us to provide a unique view of how different tools and platforms compare to each other, integrate with each other, and really what's best suited for a particular customer or requirement. We work with most of the big players in the market and have strategic partnerships with some of the big strategic vendors, AWS being one of them. Before we dive into data engineering and the role it plays today, let's take a step back and look at some of the most interesting trends and priorities in the broader data and analytics landscape, starting with digital transformation and cloud strategies. I'm sure most of you are familiar with digital transformation, or at least have heard of this term by this point. Digital transformation is about using digital technologies to reimagine your business processes and use new digital solutions to solve your problems. A prime example of this is the cloud. There's no question that the benefits of a cloud platform are massive, but how much of this benefit you're able to tap into and realize is really dependent on how you plan and execute strategies. Volume and variety of data. Data is being generated at a tremendous scale these days, and storage costs are very low. So it only makes sense that organizations want to be able to use all of this data. The more data points you have, the more informed you are, and the better equipped you are to make decisions that improve your performance and help you innovate. Along with volumes, the type of data you get is also pretty varied. So you may have structured data that you can easily organize into rows and columns, or you could have semi-structured or unstructured data that is coming in from, let's say, social media websites. The third one on my list today is user empowerment and citizen analysts. Over the last few years, organizations have invested a lot into empowering all of their users so they have the skills and know-how to interpret data, analyze data, and generate insights. So the responsibility of providing data and reports no longer sits solely with IT, and business analysts and consumers are encouraged to run their own analysis, and for that matter, they have the inclination to do so as well. Finally, data science and advanced analytics. So this has been a buzzword for a while now, but the momentum has been rapidly increasing. How can you predict and forecast future demand? How do you identify the underlying trends that could influence the market in terms of demand and supply? How do you get that extra piece of information that allows you to plan and outperform your competitors? That's where data science and machine learning comes into play. Now, this is obviously not an exhaustive list of all of the trends in the data and analytics space, but they're probably the ones that are most relevant to our topic today, which is data engineering. So what is data engineering? Data engineering relates to all of the processes that are involved in making data more accessible and useful to consumers. So from data sourcing to data transformation, and all of the data pipelines that move and store data. And this, of course, across all kinds of sources, format, and structure. So data engineering and supporting tools have been around for a while. But has it changed at all with the latest market trends? And if so, how? We'll start right from the top. So with the adoption of the cloud, and in particular data lakes, there has been a shift to central data stores, the single version of truth. Earlier, the norm was to have several standalone applications with its own ETL processes and tools. For example, finance data from SAP was ingested into 5 different applications, and you'd have pretty similar ETL processes replicated as many times. With centralized data stores, the focus has also changed to centralized and common ETL processes. To support the growing volume and variety of data, the tools themselves have needed to evolve. So they can now handle both batch, so that's scheduled jobs, or also real-time streaming data. Tools have also changed so they can read from a variety of data sources. And this connectivity tends to be a pretty important criteria when you're evaluating these tools. With user empowerment initiatives, business analysts may need to carry out additional data preparation or combine data from different sources. This led to the advent of low-code, no-code tools, basically with more user-friendly interfaces, point-and-click options. The final one around data science and advanced analytics is a pretty interesting one. So data engineering is a pretty critical part of building data science and ML models. There are plenty of stats that fly around relating to, say, 60% or 80% of the effort involved in building data science models actually pertains to data engineering. But let's leave the stats aside. The main thing is that data engineering tools come into play, either when data scientists are prepping their data before they get to the advanced analytics piece, or when data engineers and ops teams productionize these models. So when we talk about data engineering, what are the most common usage patterns? We'll start with enterprise applications. So these are the automated, validated, and trusted solutions that deliver data across the organization, typically built by your IT teams or technical developers. You then have business user-led analysis, which could be driven by the business analysts, so the same group of users that I spoke about when we were talking about user empowerment. Finally, machine learning, where data scientists develop ML models, but will need to cleanse and transform your data before they get to that advanced analytics piece. So do all of these 3 patterns employ the same set of tools? Do they even have the same requirements? Let's take a look at that, starting with enterprise applications. So the level of data engineering involved here tends to be pretty complex, and therefore the tools should have equally rich capabilities. The users developing these applications would be technically skilled, and therefore either a code-based or a visual UI would work. The tools should, however, support custom code for advanced implementation needs. Finally, it's valuable, and I'd almost say essential, that these engineering tools integrates with DevOps practices and tools. So a code repository for version management, or CI/CD pipelines for automated deployments across environments. So these are some of the features that we'd expect from a data engineering tool for enterprise applications. Let's look at business user-led analysis with a similar lens. So you will need data preparation and modeling capabilities, so the ability to join files, add calculations, cleanse data. A low-code, no-code application is probably best suited here, as it's unlikely all your business analysts will have the required coding skills. Business users will likely want to analyze the outputs of this data prep in a visualization tool. So some sort of direct or indirect integration would be a good value add. Finally, for machine learning, data engineering needs for ML modeling tends to go beyond the basic sort of cleansing and merging of data. There are specific kinds of transformation that are very relevant. Examples will be normalization of fields, encoding. So if such features can be automated, that would be pretty valuable. A low-code, no-code tool works pretty well over here, but just the option to add custom code if needed would be pretty good. And finally, from an integration standpoint, integration with ML tools like deployment pipelines or feature stores, that would be essential as well. Across all of these 3 usage patterns, though, the tools need to respond quickly and handle large data volumes. So scalability, performance, absolutely critical. Whilst there are similarities in these data engineering needs, there are still nuances between these different patterns that are important to consider when you're evaluating what's needed for your organization and your users. So now let's layer in some tools and technologies to implement all of this. The focus of today's session is obviously AWS. It is the market leader in the cloud and continues to sustain the advantage it has from being the first major cloud provider. Believe it or not, it has over 175 services. A lot. So the challenge is really in picking the service that's right for you. The services are very powerful, flexible. They're traditionally been code-based, but very developer-friendly offerings. reInvent, which is AWS's big annual event, tends to be the time when a lot of new product releases come out, and it was pretty much the same this time around as well. There's been a lot of interesting developments with a focus on visual user interfaces, but also tools that go beyond the sort of the technical user base and bringing in a different group of users. I should also highlight that if your underlying platform is on AWS, you're not just restricted to the native AWS data engineering tools. There are other third-party tools with very strong integration. So Databricks or Matillion and Redshift would be just a couple of examples. In this webcast, though, we are going to focus on the native AWS tools and explore how they line up against those three usage patterns that we'd outlined. Starting with enterprise applications. So the tool that I'm going to introduce over here is called AWS Glue. It is one of the premier AWS ETL tools, and it has been around for a while. Just to give you a bird's eye view of this offering, let's look at some of its main features, starting with the Glue catalog. So this is a central repository where you can configure and keep track of all your data stores, be it files or folders in an S3 data lake, or just tables in a database. You can use crawlers to scan and determine the schema of these objects, and that schema can in turn be used within your ETL job, which brings us to the core ETL services. Glue Studio, that screenshot that you see over there, is the new interface that was released just last year, providing a UI-based approach to development. You always have the option, of course, to write sort of complex jobs just using code. So you set up a job for your data movement and transformation operations. You can schedule this as needed. You can also combine multiple jobs into a workflow in case you want to set up a chain of operations with dependencies between them. And finally, a key pillar of AWS's framework is security. And true to that, all AWS Glue services are highly secured. And you can enable encryption to ensure that the data in your catalog, in your jobs, in your execution logs, they're all secure. So that's a very quick overview of AWS Glue, which we think is a service that's pretty well suited to meet your data engineering needs of the enterprise application. So that first box there. I'll now hand over to Emily, who will walk you through a demonstration of AWS Glue and then take it forward with the rest of the usage patterns.
All right. Thank you, Archana. Hi, everyone. This use case to demonstrate how Glue Studio works and how it can potentially be integrated into an enterprise data landscape. All right. Some background for this demo. We are now financial analysts for the fictitious TG Goods, a CPG company that manufactures and sells food products, household goods, cosmetics, office supplies, and so on. TG Goods stores all of its raw data in one large repository, this raw S3 bucket that we see here. Then each business unit, so R&D, marketing, finance, and so on, will reach into that bucket and pull relevant data for analysis and reporting. From our perspective, we're interested in pulling data from this raw bucket into our finance bucket. Once it's in our finance bucket, we can further clean and engineer this data for analysis. Again, we're approaching this as the finance team. So to pull this data, we're going to ask our IT team to author a Glue job to provision finance-specific raw data in our finance bucket. We're then moving that data to Redshift for more focused analysis and reporting. This first demo is going to focus on the first Glue job that you see here, and disclaimer, most real jobs will be a bit more complex. we're just going to show a simple watered down example. Once you're in AWS Management Console and you navigate to AWS Glue, this is the landing page that you'll see. So on this left menu over here, we have our data catalog, which contains all of our database information, so tables and connections. We then have all of our crawlers, which Archana touched on briefly, but a crawler is essentially going to infer metadata into your data catalog. We then have schema registries, and then we get down to our ETL specific menu. So AWS Glue Studio, we can define and create workflows, jobs, triggers, endpoints, and then here at the bottom we have our security configurations. We're going to look at Glue Studio real quick. This is a relatively new feature. So if I want to create an ETL job in Glue Studio, I'm just going to click on Create and Manage Jobs, and then I have the option to define kind of a source and target. And in this specific demo case, we are going from an S3 source to an S3 target. So I'm going to leave that as kind of the default setting and create a job. So once we're in Glue Studio, this is the interface that we kind of land on. There are essentially, this is set up in nodes. So each of these kind of boxes is referred to as a node. There are essentially three types of nodes. We have source nodes where we pull from a data source. We have transformation nodes, so we can apply some basic transformation functions, like dropping columns, renaming columns, and so on. And then we have source nodes. So this is where we're putting our transformed data. I'm going to just flick over. I've created a simple job to extract data from this raw bucket into our finance bucket. So I'll just kind of walk you through this real quick. I have two source nodes. Both are coming from the raw S3 bucket. One refers to product data right here. The other refers to, or is pulling sales data from that raw bucket. I'm then going to rename one of the columns in product in order to join these two tables. I'm using a join node here. Then I have a drop node just to pull out some of the columns that aren't relevant to the finance team. And I have my data target node here. So I'm placing my transformed data into the finance S3 bucket. This is what my ETL job visually looks like. And then we can flip over to the scripted version. So as I'm building out this job in the visual interface, I also can kind of see the Python code that is being written behind that interface. I can then define job details, so I can name the job, assign, and so on. I can view my runs, and I can create schedules, so if I want to run this on a specific cadence. But yeah, so that's a pretty brief overview of Glue. So that was just a pretty high-level example of how we could use AWS Glue to get from that raw bucket to finance. Back to our common usage patterns. We just touched on Glue, which generally falls into the enterprise application silo here. But let's take a closer look at AWS from the business user-led analysis perspective. Again, from this perspective, we're generally looking for data preparation and modeling capabilities, a low-code or no-code environment, and pretty easy integration with either visualization or reporting tools. And this kind of brings us to AWS Glue DataBrew. So DataBrew is a visual data preparation tool with rich data transformation capabilities that can be applied through a low-code, no-code, point-and-click user interface. DataBrew was released actually rather recently and is particularly suited for ad hoc and repeatable analysis. The interface is similar to Power Query or Trifacta, if you're familiar, in that it allows you to view your data in tabular form, making it very visual and business user-friendly. The service includes pre-built features and functions that streamline the cleaning and engineering process. So, example, remove duplicates, split columns, or other common cleaning or engineering processes. And as it is an AWS service, it integrates well with other AWS services, especially for networking, management, or governance. So think like CloudFront, CloudWatch, step functions, and so on. From a data engineering perspective, there are essentially four main components or aspects of DataBrew. The interactive data prep workspace is called a project. So using a project, you manage a collection of data transformations and scheduled processes. Recipes, as they're referred to, are the chronological application of data engineering instructions. So for example, step 1, remove blank values from column C. Step 2, split the date column into years and months, and so on. A job is the process of going through a recipe that you've created. Jobs can be run ad hoc or on a schedule. And Glue DataBrew also creates a data profile of your data, which is essentially a summary that tells you the context of the content, the data structure, relationships, and some data quality information. Okay, that was a quick overview of Glue DataBrew. Back to our architecture here for the demo. We're going to clean and engineer some of our finance data for a cosmetics report. So we're going to pull data from our finance bucket and then create a project in DataBrew. So from your management console, when you search for Glue DataBrew, this is your landing page. Just a brief walkthrough. We have access to our data sets, projects, recipes that we've already created, jobs, and kind of a what's new tab. I'm going to flip over to a pre-created project. We'll just kind of walk through this interface quickly and do a quick transformation. So I have a preview of my data in front of me right now, and I can kind of toggle between this grid view that I'm looking at right now. I can switch to a schema view, and there's also a profile view, but that requires a little bit more kind of compute power for some analytics. So we're just going to stick with our grid view for now. I have this top menu with basic but commonly used engineering and cleaning functions like remove duplicates, split columns, apply a math or text function or aggregate function. Let's switch over to this recipe right now. So I've already applied some engineering and cleaning steps to my data. So if I click on recipe, I can see those steps and the order in which they were applied. So I've switched the order of some columns here. I've created a new column. I've deleted a column. I've created a column using a math function, changed the format of data, and so on. So if I want to add to this recipe, let's say for the sake of this cosmetics report, I only want item type cosmetic. Let's kind of just walk through how I would do that. There are a few ways to go about it, but I'm just going to add a step to my recipe right here. And we're going to filter by condition. I'm going to select my column name, which is item type in this case. Filter condition, there are probably a few ways to do this, but I'm just going to go with contains. I could preview those changes, but I'm pretty confident that this is going to do what I want it to. So I'm just going to apply that real quick. And that added another step to my recipe, and it filtered on cosmetics. And just a quick look into some of those features we were talking about earlier in the presentation. I'm just going to click on a column here. Let's go with units sold. You can see I have some column statistics that DataBrew has just kind of automatically produced. So I can look at my data quality if I'm missing any values, the distribution of my data, median, mean, mode information, which can be very helpful. The final step here would be to create a job, which is going to place this cleaned data in a location of choice. So in this case, I just created a job to put this cleaned report back into my finance bucket, which is in a separate folder. Okay, so that was a quick overview of DataBrew. Moving to machine learning. Data engineering needs for machine learning models tend to go beyond the baseline cleaning and merging of data. A low-code, no-code tool would work pretty well, but we also want the option to write code if needed. And then perhaps not surprisingly, we want a service here that will integrate easily with ML tools, be it deployment pipelines or feature stores, so on. And with that, we have Amazon SageMaker Data Wrangler. Data Wrangler is similar to AWS Glue DataBrew with some additional functionalities geared towards machine learning and integration with SageMaker. It's another no-code optional tool used for data preparation. with a similar but Jupyter-based UI. In Data Wrangler, you can create your recipe, as you saw in DataBrew, by selecting transformations from a list or customizing them with code if you choose. There are options to perform an easy analysis of your data with built-in data visualization tools and data analysis. And then you can export your recipe with those transformation steps to Python code that can be used in your SageMaker ML projects. All right, before we close out today, I want to offer some next steps in regards to data engineering with AWS. First next step here would be to evaluate existing data engineering tools and usage patterns within your organization. With that comes speaking with your colleagues to collectively gauge the data engineering landscape at your organization. Start to ask questions. Are the tools currently in use working for everyone? Are business needs being met? If you're looking to evolve, identify your main requirements. There are so many tools out there, it's worth putting in some time to run through proofs of concepts and proofs of value. And if you are keen on learning more about AWS for data engineering, we are hosting an AWS for data engineering taster on February 25th in the US and on March 25th out of the UK. This is going to be a longer format workshop that will provide a broader scope of the AWS environment. We're going to walk through different architectures and considerations and give attendees the opportunity to get some hands-on experience with some of the services. We also have a nice variety of AWS and data engineering resources on our webpage, so webcasts, blogs, case studies. I would encourage you to explore and dig around a bit. We also have a few upcoming events on our calendar, but really we have a variety of topics and technologies that we're going to cover in the next few weeks. So on behalf of Archana and myself, I want to thank you for joining us today. Again, our contact information is on the screen, and that is intentional. Please reach out with any questions or comments. And with that, we'll conclude the webcast. So thanks again and have a nice day.